Last lesson, we used the method of difference to evaluate a series. This lesson, we will conclude the section on evaluation of series with the final section on evaluating series by applying a given formula. Now, when we say given right over here, what it means is that the formula for a particular type of series is either printed in the question or we are asked to show a certain formula holds and hence use it to prove something else about a different series. So that is either it is printed or it is a hence type of question. Now, what do we mean when we say we are applying a given formula? In fact, there are certain conditions which have to hold before we can apply a given formula. What this means is basically, first of all, our lower limit must be r equals to n. And secondly, the function must be in terms of r. What does this mean? Now, let's take a look at question 10 for a better idea. In example 10, we are given that this particular formula holds. So this is the given formula. Okay, please take a note because many students later on do not really understand what it means when we are using a given formula. Okay, so now that we know what the given formula is, let's check back against the conditions for us to apply. Now, since we are given this formula, what exactly is it that is left for us to evaluate? In fact, the sums that we need to evaluate are this sum, the sum from r equals to 0 to r equals to n plus 1 of r squared. And in part B, we are asked to evaluate these are the sum. Now, in order for us to apply the formula, let us check back and see that these two conditions have to hold. So firstly, our lower limit must be the same as the lower limit given in the formula. So taking a look at example 10, what we see is, in fact, our lower limit is not the same. Now, while we are given that the lower limit for the formula is r equals to 1, in our question itself, the limit given is r equals to 0. So this means that our lower limit is not the same. So some manipulation must be done. Before we can use the formula. Now the second thing, or the second condition which must hold is that the function here must look exactly the same. So let's take a look. Over here, the function is r squared. And in example 10 part A, the function given is also r squared. So this is very good for us. It means that for this part, it is the same. So the only thing we are concerned about is with the lower limit. I hope you can recall from an earlier lesson that we can in fact shift the lower limit back by 1. Now, instead of summing from r equals to 0, if I were to start from r equals to 1, I would need to compensate with the term for r equals to 0. Okay, and hence this is the same as taking the sum from r equals to 1 to n plus 1 at the term for r equals to 0. Now, how then can we apply our formula? Is it exactly the same as the formula that is given? Take a look carefully. In fact, we can see that while over here, in the given formula, we are summing to n, in this question part A, we are asked to sum to n plus 1. Is this going to be a problem? If you were to think about it, you would realize that it is in fact not a problem. And all it means is that we are going to have to replace all the n in the formula with n plus 1. So let's look back at our formula. Where do all the n's occur? Can you see that there is a n over here, as well as over here. So each of these n's highlighted in red will have to be replaced with n plus 1. Now, so my summation is hence going to be 0 plus n plus 1 over 6, which is from this part over here, followed by n plus 2 and multiplied by 2 times n plus 1 plus 1. And upon evaluation, eventually what you should get is this in simplified form. Okay, so that was a simple example on how we can use a given formula to evaluate a series. Now let's take a look at something that looks slightly more complex in part B. Well, this looks intimidating, right? In fact, it is actually quite simple. Now all you have to bear in mind is that you are given a particular formula, so you have to use all ways and means to manipulate whatever it is you are asked to evaluate to ensure that your formula can be applied. So if we were to look carefully once more, what we see is we know how to sum r squared, and we are asked to find this sum. Now, is there any similarity at all? It seems like there is no square at this point in time. But if you take a closer look, you see that this is actually a quadratic equation, which means that, in fact, we can expand to get a r squared term, which means that we can apply our formula. So do you see the thinking process here? What we are doing is we are making a comparison between what is given and what we are asked to evaluate, and see what are the steps that we need to take in order to be able to use what is given to us. Okay, so that we will have less work to do. So like I mentioned earlier, we will have to expand, and upon expanding, what we get is this. Now, what is the next trick? Remember that we can in fact split up a sum, right? So this is going to be equal to sum from r equals to 1 to 25 of 2 minus a sum r equals to 1 to 25 of r minus a sum r equals to 1 to 25 of r squared. Okay, this part over here is simply achieved by breaking up the sum. Now what is the next thing we can do? Perhaps some of these parts are starting to look a bit familiar. I don't know if any of you can remember how to sum a constant. I'll write down the formula over here at the side. Okay, r equals to 1 to n of a constant k, which is independent of r, is simply going to be n times of k. So in this case, this sum is going to be given by 2 times 25. What about this part boxed up in green? Do you recall that this is in fact a sum of a AP? This was actually covered just before we did method of difference. And finally, what about this part then, boxed up in blue? Aha! Over here, we see that our lower limit is already the same at r equals to 1. Our function itself, r squared, is also the same. All that is different is, instead of summing to a value of n, we are taking a sum to 25, which means that I am going to substitute n equals to 25 into my formula, and hence what we get is this line over here. Okay, so in orange, this is from the sum of a constant. In green, please write down, this is from the sum of a AP. And finally, in blue, this is the sum using the given formula. And if you punch this into your calculator, eventually you should get a value of negative 5,800. Moving on, let's look at something slightly more complex, which is more likely to come out in an examination. Let's take a look at example 11. Indeed, it is a mid-year exam question from 2010. So let's take a look and see if you would be able to do this if this question came out on your mid-year exam. Take 30 seconds to think about it. And when you're done, continue with the video.